and the population is increasing by 20% each year. Give a model for population P in T years. What is the population in 5 years? And round your answer to nearest one. Okay, so the question is straightforward. They gave me the percent increase. I just have to add the percentage to the 1 for my growth factor. So in this model, y equal a times b to the x, instead of growth factor, I'm going to use this 1 plus r to the x, and plus because it's increased. So my r was 20%, which means 0.2, and then my growth factor b, which is 1 plus r, is 1 plus 0.2, so it's 1.2. And the initial amount, or A, is just 2,600. So what do I have? Y equal 2,600 times 1.2 to the x. And then to write it in P for P and T, population after T years is going to be 2,600 times 1.2 to the T. So this is the model for this situation, for this question. So this is for the first part, and then for the second part, it says what is the population after 5 years? So all I have to do is just plug in the 5. So the population after 5 years is 2,600 times 1.2 to the 5th power. So if you do that in your calculator and then round your answer to the nearest one, you're going to get something like, okay, so the population after 5 years is, use your calculator, 1.5 to the 5th power, and then multiply it by this number here. So you're going to get 6470 if you round it to the nearest one. So this is the population after 5 years for the second part. Alright, here we have another question. $3,000 is invested in an account that pays 6% interest annually. Come up with a model for the amount A in the account after T years. After 2 years. So this is the percentage and this is the initial amount that we started with. So for part A, in the model y equal a times b to the x, I have a percentage, so instead of b, I'm going to write 1 plus r, and it's increasing, so it's plus r. 1 plus r to the x. And then my initial amount is 3,000 times 1 plus 6% is 0.06 to the x. And then to write it in terms of A and T, my model would be A equal 3,000 times 1.06 to the T. So this is the model for this bank account for part A. Okay. Part B is asking how much is added to the account to the initial amount after 2 years. So what I have to do is to find how much is in the account after 2 years, and to see, and then we'll figure out how much is added to the initial amount. So after 2 years, all I have to do is just plug in 2 for T in this formula. So the amount after 2 years is 3,000 times 1.06 to the second power. And remember to do the order of operations correctly. So 1.06 to the second power, and then whatever you get times this number. And if you do that on your calculator, you're going to get 3370.8 8, and then if you round this to the nearest dollar, it would be 33.71. So how much is added to our account? So this is the final amount that we have after 2 years, and how much we had at the beginning was 3,000. So if we subtract this, we're going to get $371 after 2 years is added to our account. So this is it for part B. Okay, part C is asking me how much should be invested in the same account to get $5,000 in 2 years. So I have this model from part A, but I want this A to be 5,000. So that means how much should I invest in this account to so that after 2 years I get $5,000. So this 2 years tells me that my T here is 2. So I want $5,000, and I don't know my initial amount. I'm looking for the initial amount, and it's 1.06 to the second power. So to solve for A, divide both sides by 1.06 squared, and our A is, if you use your calculator, you're going to get this number, and then if you round off to the nearest dollar, you are going to get $4,450. So that means if we invest this much money into the account that pays 6% interest annually, we're going to get $5,000 after 2 years. So this is it for part C, and this is the final answer for part C, and that's it for this question. Alright, here's the last example for you to try. Go ahead and pause the video. We'll go over it together. Alright, a colony of bacteria starts with 4,000 bacteria. During an experiment, 45% of them dies off each week. How many are there in 35 days, and then round your answer. So we start with 4,000, so that's our initial amount, and then 45% of them die. So 45% is the percent decrease, but for my B, for the decay factor, I need to know how much of the bacteria remains. So I'm going to have to use the 1 minus R formula. So to the x, and then my growth factor is percent decrease is 45%, which means 0.45. And then my growth factor, which is 1 minus R, is 1 minus 0.45, which is 0.55. So here in this equation, in the model, my initial amount was 4,000 times 0.55 to the x, and then to adjust the variables, you can say the population in T weeks. T is the unit of T is weeks, because the situation is given to me in weeks, and then is 4,000 times 55 to the T. And they're asking me how many bacteria are there in 35 days, but notice that the unit of this T is weeks, so I have to convert the 35 days to weeks. So, and each week has 7 days, so actually it goes up. Each week has 7 days, so we just divide 35 by 7, and then we get 5. So So that means 37 days is equal to 5 weeks. So I just have to plug in this 5 into here to see what is the population after 5 weeks, or 37 days, 35 days. So the population after 5 weeks is 4,000 times 0.55 to the 5th power, and then if you use your calculator and remember to do the order of operations correctly, first raise the power of 0.55 to 0.55 to the 5th power, and then multiply it by 4,000. You're gonna get and then you have to round your answer because they're asking us to round our answer. So you're gonna get approximately 201. So this is the number of bacteria that remain after 35 days. Alright, that's it for exponential growth and decay applications. Thanks for watching this video.